Welcome. You have nothing to do right now, nowhere to be, nothing to figure out. Simply let your body soften into wherever you are resting and allow your breath to slow. Tonight, we are going to drift gently outward through the quiet, vast reaches of our solar system. Let each word wash over you like a slow, warm tide. You are safe, you are still, and all is well. The sun holds nearly everything. At the heart of our solar system sits the sun, and it contains 99.26% of all the mass in this vast family of worlds. Everything else, every planet, every moon, every drifting asteroid and wandering comet makes up just a tiny fraction of what remains. It is a humbling thought, held gently. The sun is not just a star at the center. It is, in almost every measurable sense, the solar system itself. Our sun is a yellow dwarf, a G-type main sequence star. Among the many kinds of stars scattered across the galaxy, our sun belongs to a calm, steady, middle-aged family known as G-type main sequence stars. The name yellow dwarf is a little misleading to our eyes. The sun shines a brilliant white, but measured by the full spectrum of its light, it falls into this gentle, moderate category. It is neither the largest nor the smallest, neither the hottest nor the coolest. It is, in the most comforting sense, just right. Deep inside the sun, temperatures reach about 15 million degrees Celsius. At the very core of the sun, conditions exist that are almost impossible to imagine from the quiet of a resting room. The pressure there is immense, and the heat is extraordinary, around 15 million degrees Celsius. Yet even this staggering fact can be held with a kind of wonder rather than alarm. That fire burns steadily, reliably, day after day, year after year, warming every corner of the solar system from an unimaginable distance away. Every second, the sun fuses 600 million tons of hydrogen into helium. Inside that blazing core, nuclear fusion is always quietly at work. 600 million tons of hydrogen are transformed into helium every single second, and in that transformation, a tiny fraction of mass becomes pure energy, the light and warmth that reaches us across space. It is an ancient, continuous process, as steady as breathing, as reliable as morning. The sun has been doing this for a very long time, and it will continue long after any of us can imagine. The sun has existed for approximately 4.6 billion years. Our sun is middle, aged by stellar standards. It formed about 4.6 billion years ago from a slowly collapsing cloud of gas and dust, gathering mass until the pressure at its center was enough to ignite fusion. The Earth formed from the leftover material of that same ancient cloud. In a very real sense, we are children of the same moment. The sun, the earth, and everything on it, born together from the same quiet turning of ancient dust. The sun will remain stable for another 5 billion years. There is no hurry to the sun's life. Scientists tell us it still has approximately 5 billion years remaining on what they call the main sequence, the long, steady phase of its life, where it burns hydrogen calmly and consistently. 5 billion years is a number so large it dissolves into pure peace. For now, and for all of human time, the sun simply shines. Steady, warm, and enduring, it will be there when morning comes. The sun's visible surface, called the photosphere, glows at about 500 degrees Celsius. When we look at the sun, carefully, safely, what we see is a layer called the photosphere. It is the sun's visible surface, glowing at around 500 degrees Celsius, releasing the warm golden light that travels across space to reach us. The photosphere shimmers and moves in slow churning patterns called granules, each one the size of a small country, rising and falling in a quiet, continuous dance of heat. The sun's outer atmosphere, called the corona, reaches temperatures exceeding 1 million degrees Celsius. Beyond the photosphere, the sun's outermost atmosphere, the corona, stretches into space in delicate, glowing streamers. Strangely, it is far hotter than the surface below it, reaching temperatures of over 1 million degrees Celsius. Scientists are still working to understand exactly why this is so, and that quiet mystery is one of the sun's most beautiful puzzles. During a solar eclipse, the corona appears as a soft, shimmering halo of white light around the darkened sun. The sun rotates faster at its equator than at its poles, a phenomenon called differential rotation. Unlike a solid ball spinning all at once, the sun is made of gas and plasma, and different parts of it rotate at different speeds. Its equator completes a rotation in about 25 days, while the poles take closer to 35 days. This gentle, uneven turning is called differential rotation, and it slowly twists and winds the sun's magnetic field over time. It is a slow, fluid motion, like watching honey turn in a jar, unhurried and deeply patient. Sunspots are cooler, darker regions on the photosphere caused by concentrations of magnetic energy. Scattered across the bright surface of the photosphere, sunspots appear as quiet, dark patches, regions where intense magnetic fields slow the flow of heat from below, making those areas slightly cooler and darker than their surroundings. They are still extraordinarily hot, around 3,500 degrees Celsius, but against the blazing brightness around them, they appear as soft, shadowed islands. They drift slowly across the sun's face over days and weeks, like slow clouds passing across a golden sky. Solar flares can release energy equivalent to billions of nuclear bombs. Occasionally, the sun's tangled magnetic fields snap and realign in a sudden, brilliant release of energy called a solar flare. These bursts are among the most powerful events in our solar system, releasing energy equivalent to billions of nuclear explosions. Yet from where we rest here on Earth, they appear only as a brief brightening on the sun's distant face. They are immense, and yet they leave our world quietly unchanged, a reminder of how gently the universe holds us. The sun emits a constant stream of charged particles called the solar wind. Flowing outward from the sun in every direction, a gentle but endless river of charged particles streams through the solar system. This is the solar wind. It moves at hundreds of kilometers per second. Yet it is so diffuse that we cannot feel it. It brushes past planets, shapes the tails of comets, and fills the vast space between worlds with a quiet, invisible breath. The entire solar system is wrapped inside this slow, continuous exhale. Light from the sun takes about 8 minutes and 20 seconds to reach Earth. When sunlight falls on your face, that light has been traveling for just over 8 minutes, crossing nearly 50 million kilometers of empty space to reach you. It left the sun before you last glanced at the clock. It journeyed in perfect silence through the darkness between worlds, and then, softly, it arrived. There is something deeply peaceful in that thought, that warmth and light make such a long, quiet journey just to find us. The sun's diameter is about 10⁹ times that of Earth. If you place the sun and Earth side by side, our entire world would look like a small pebble resting beside a great, glowing sphere. The sun is so wide that more than 1 million Earths could fit inside it, and yet, on the scale of the galaxy, the sun itself is just one quiet, ordinary star among hundreds of billions. Scale has a way of making everything feel both small and wonderfully, peacefully significant at the same time. Mercury is the smallest planet in the solar system. Moving outward from the sun, the first world we encounter is Mercury, small, quiet, and ancient. It is the smallest of the 8 planets, only a little larger than Earth's moon, a compact rocky sphere, worn smooth and pitted by billions of years of history. There is something endearing about Mercury's smallness, the way it holds its place closest to the sun, unhurried and unassuming, a tiny sentinel at the inner edge of our planetary family. Mercury is the closest planet to the sun, orbiting at an average distance of 57.9 million kilometers. Mercury traces its path through space closer to the Sun than any other planet, at an average distance of about 57.9 million kilometers. From Mercury's surface, the Sun would appear nearly 3 times larger in the sky than it does from Earth, a vast, blazing presence filling the horizon. And yet Mercury orbits in patient silence, a small rocky world holding its steady course in the warmth of the Sun's nearness. Mercury completes one orbit around the Sun in just 88 Earth days. Mercury moves through space with a quiet swiftness, completing its full journey around the Sun in only 88 of our days. While Earth takes a full year to make that same circuit, Mercury traces its smaller, tighter path in less than 3 months. It is always in motion, always curving gently around its star, a small world in steady, faithful orbit, looping around the Sun again and again in its own unhurried rhythm. Mercury rotates so slowly that one Mercurian day lasts 59 Earth days. While Mercury races around the Sun, it turns on its own axis with extraordinary slowness. A single Mercurian day, one full rotation, takes about 59 of our Earth days. This means that on Mercury, the Sun moves across the sky with an almost imperceptible patience, rising and setting over weeks rather than hours. Time there unfolds at a different pace, slow and ancient, as if the planet itself has learned a deep and unhurried stillness. Mercury has no atmosphere to retain heat, causing temperature swings from 430 degrees Celsius to negative 180 degrees Celsius. Without an atmosphere to hold warmth or shade, Mercury experiences the most extreme temperature swings of any planet. In sunlight, its surface bakes at 443 degrees Celsius. In shadow, it plunges to negative 180 degrees. The same small world holds both scorching heat and profound cold, separated only by a line between light and dark. It is a place of quiet extremes, a world stripped bare beneath the open sky of space. Mercury's surface is heavily cratered and resembles Earth's moon. Looking at Mercury's surface, one is struck by how familiar it feels. A quiet world of craters, plains, and ancient ridges, worn by billions of years of impacts from passing rocks and debris. It bears a close resemblance to our own moon, gray and still and time-worn. Each crater is a record of a long-ago moment, now frozen in silence. Mercury's face tells the slow story of the early solar system, written in stone and preserved in the stillness of space. Let yourself settle a little deeper now. There is nothing to hold on to, nothing to figure out. Let your shoulders soften, let your jaw release, let your hands rest open and easy. Each breath you take is a little slower, a little quieter than the last. You are safe, you are still, and the only thing asked of you right now is simply to rest. Let the gentle facts of the solar system drift through your mind like slow light across a vast and peaceful sky. The Caloris Basin on Mercury is one of the largest impact craters in the solar system. Long ago, something enormous struck Mercury, carving out a vast circular scar nearly 1,500 kilometers across. The Caloris Basin is one of the grandest impact features in all the solar system, a wide, ancient bowl of ridged and rippled stone. It lies quietly now, worn smooth by time, a reminder of a distant moment now long stilled. Its name means warmth. It faces the sun at Mercury's closest approach, bathed in slow, steady light. Mercury has a surprisingly large iron core, making up about 85% of its radius. Beneath Mercury's quiet, cratered surface lies an enormous iron core, stretching through nearly the entire width of the planet. Scientists believe this core is partly molten, slowly cooling over billions of years. It gives Mercury a density far greater than its small size would suggest, as though the planet carries a quiet, hidden weight at its very center. There is something deeply peaceful in imagining that still, dark interior, resting undisturbed in the deep of space. Mercury has no moons. Of all the planets, Mercury travels entirely alone, with no moon to accompany it on its swift journey around the Sun. No satellite rises over its cratered horizon. No reflected light crosses its ancient plains at night. It orbits in quiet solitude, just itself and the distant glow of the Sun. There is something restful in that simplicity. A small world moving through space with nothing extra, nothing added, just the steady pull of its star and the long open dark. The Messenger spacecraft was the first to orbit Mercury, arriving in 2011. For years, Mercury was known only from brief flybys, glimpsed in passing. Then, in 2011, the Messenger spacecraft settled gently into orbit and began a long, patient study of this small world. Over 4 years, it circled Mercury thousands of times, mapping its surface, measuring its magnetic field, reading the quiet signals of its ancient geology. It was a careful, unhurried act of discovery, a human-made craft resting in the gravity of a distant world, slowly learning its secrets. Venus is the hottest planet in the solar system, despite not being the closest to the Sun. Though Mercury sits closer to the Sun, it is Venus that holds the title of hottest planet. Venus wraps itself in a thick, dense atmosphere that traps heat with remarkable efficiency, holding warmth far beyond what proximity to the Sun alone could explain. It is a quiet lesson in how much an atmosphere shapes a world. Venus glows in our night sky as the brightest natural object after the Moon, serene and luminous, its fierce interior hidden beneath a veil of pale cloud. Venus has a surface temperature of about 40–65 degrees Celsius due to a runaway greenhouse effect. The thick atmosphere of Venus acts like a great, slow blanket, trapping heat from the Sun and never releasing it. Carbon dioxide and other gases absorb warmth and radiate it back down to the surface, building and building over eons until the temperature settled at a steady, scorching 465 degrees. Scientists call this a runaway greenhouse effect, a process that once began continued without pause. The surface of Venus is hotter than an oven, hotter than melting lead, yet from a distance it glows with a soft and gentle light. Venus's atmosphere is composed of 96% carbon dioxide with clouds of sulfuric acid. The air of Venus is almost entirely carbon dioxide, dense and heavy, pressing down with enormous weight. High in the atmosphere, clouds made of tiny droplets of sulfuric acid drift in slow, pale bands, reflecting sunlight back into space and giving the planet its brilliant glow. Beneath those clouds, the sky would be a dim, orange twilight, the Sun barely visible through the thick haze. It is a world clothed in its own quiet strangeness, utterly unlike our own, yet part of the same family of worlds. Venus rotates backwards compared to most planets, a motion called retrograde rotation. While most planets spin in the same direction as their orbit around the Sun, Venus turns the other way, slowly and steadily in reverse. This is called retrograde rotation, and Venus is one of the very few worlds in the solar system to do so. On Venus, the Sun would appear to rise in the west and set in the east, a quiet inversion of everything familiar. Scientists believe this unusual spin may be the result of an ancient collision or the slow influence of gravitational forces, reshaping the planet's motion over deep time. A day on Venus is longer than its year. Venus takes about 2043 Earth days to complete one full rotation on its axis, but only 2025 Earth days to travel once around the Sun. This means that a single day on Venus, from one sunrise to the next, lasts longer than an entire Venusian year. Time moves in a different rhythm there, slow and deep, the planet turning so gently that it completes its journey around the Sun before it has even finished one full spin. It is a world where the very meaning of a day stretches into something vast and unhurried. Venus is nearly the same size as Earth and is often called Earth's twin, Of all the planets in the solar system, Venus comes closest to matching Earth in size, with a diameter only about 640 kilometers smaller than our own world. They formed from the same ancient cloud of gas and dust, in the same region of the early solar system, and for a time may have seemed like mirror images of one another. Yet the two worlds have followed very different paths through time, one becoming a gentle cradle of life, the other a world of heat and silence. There is something quietly moving about that. Two sisters, so alike in form, so different in fate. There is nothing you need to do right now, nowhere to be, nothing to hold on to. Let your shoulders drop a little, let your hands rest open and still. Feel the gentle weight of your body settling, sinking softly into wherever you are lying. With each slow breath out, let a little more of the day dissolve, the thoughts, the sounds, the small concerns. You are safe, you are still, and the night is quiet all around you. Simply rest here, drifting gently, as the universe turns slowly on, without you needing to do a thing. Venus has no moons. While Earth has its constant companion in the night sky, Venus travels alone, unaccompanied by any natural satellite. It drifts through its slow orbit around the Sun in quiet solitude, no moon pulling at its surface, no reflected light hanging above its clouded skies. Scientists have offered several explanations. Perhaps Venus never captured a passing body, or perhaps an ancient moon was lost long ago through gravitational forces. Whatever the reason, Venus moves through space in its own unhurried way, alone and self-contained, a world of one. The surface pressure on Venus is about 92 times that of Earth at sea level. Standing on the surface of Venus, a person would feel the weight of the atmosphere pressing in from every direction, with the same force felt nearly a kilometer beneath the surface of Earth's oceans. That immense pressure comes from the sheer density of Venus's thick carbon dioxide atmosphere, layer upon layer of heavy gas stacked high above. The earliest spacecraft to land on Venus were crushed within hours. Yet from far above, the planet rests quietly beneath its clouds, serene and glowing, keeping its surface hidden and still. Maxwell Montes on Venus is the tallest mountain on the planet, rising about 11 kilometers above the surface. This great highland peak sits within a vast elevated region called Ishtar Terra, a plateau larger than the continental United States. Maxwell Montes rises steadily from those high plains, its upper slopes dusted with a metallic frost, made of minerals that condense in the cooler air at altitude. It is a mountain of quiet enormity, unseen beneath the clouds, known only through the patient radar eyes of orbiting spacecraft. A summit that no one has ever stood upon, rising in silence beneath an amber sky. Venus has thousands of volcanoes on its surface, many potentially still active. More volcanoes have been identified on Venus than on any other planet in the solar system, tens of thousands of them scattered across the lowlands and highlands alike. Some are ancient and long quiet, their flanks worn smooth by time. But scientists believe that at least some may still be active, releasing heat and gas from deep within the planet. Recent observations have offered hints of fresh volcanic flows, warm and new against the old rock. Beneath the clouds of Venus, the planet may still be breathing, slowly and deeply, in its own hidden way. Earth is the only known planet to harbor life. Of all the worlds in the solar system, the scorched plains of Mercury, the crushing clouds of Venus, the frozen deserts of Mars, only this one, our small blue world, is known to be alive. Life here is woven into every layer of the planet, from the deepest ocean trenches to the highest reaches of the atmosphere. It fills the soil, the ice, the air, the dark places beneath the crust. Earth hums with life, in ways both vast and invisible, and in all the known universe. No other place has yet been found to do the same. We are, as far as we know, the only one. Earth's atmosphere is 78% nitrogen and 21% oxygen. The air we breathe is mostly nitrogen, an invisible gentle gas that dilutes the oxygen and keeps the chemistry of life in careful balance. The oxygen, that vital 21%, is the gift of billions of years of photosynthesis produced by ancient bacteria and plants slowly filling the sky with their exhaled breath. The remaining fraction holds argon, carbon dioxide, water vapor, and traces of other gases, each playing its quiet role. Every breath you take right now draws in this ancient mixture, this soft, invisible gift that wraps the whole planet in a living shell. Earth is the densest planet in the solar system. Despite not being the largest, Earth packs more mass into each unit of its volume than any other planet. This density comes from its deep interior, a core of iron and nickel compressed under enormous pressure, surrounded by layers of dense rock and mineral. The whole planet is a carefully layered sphere of heavy material, pulled inward by its own gravity over billions of years. It is a world of great inner substance, solid and grounded, its weight a quiet testament to the forces that shaped it long before any life arose upon its surface. Earth's magnetic field is generated by its liquid iron outer core and protects life from solar radiation. Deep beneath our feet, liquid iron swirls slowly in vast currents, driven by the planet's heat and rotation. This movement generates an invisible magnetic field that extends far out into space, curving around the planet like a great, gentle shield. When charged particles from the sun stream outward on the solar wind, the magnetic field quietly deflects them, guiding them away or channeling them toward the poles where they bloom into the soft curtains of the aurora. Without it, the surface of Earth would be exposed to radiation that life as we know it could not survive. It is an invisible protector, ancient and steady, turning quietly in the dark. Earth has one natural satellite, the Moon, which is unusually large relative to its host planet. Most moons in the solar system are small compared to the worlds they orbit, but our Moon is remarkably substantial, about 1/4 the diameter of Earth itself. It hangs in our sky closer and larger than any other natural satellite relative to its planet, a constant, luminous companion. Scientists consider this pairing so unusual that they sometimes describe the Earth and Moon together as a kind of double world, two bodies bound in a slow, graceful dance through space. The Moon is slowly drifting away from Earth at a rate of about 3.8 centimeters per year. It is a movement so gentle it cannot be felt or seen, a quiet recession measured only by laser pulses bounced off reflectors left on the lunar surface by Apollo astronauts. Over millions of years, this gradual drift adds up, and the Moon was once much closer, its presence larger in the ancient sky. Even now it moves away, unhurried and steady, like a companion slowly walking ahead into a vast and quiet field. There is nothing you need to hold on to right now. Let your thoughts drift the way clouds drift, slowly, without direction, without effort. Feel the weight of your body settling a little more with each breath, each exhale releasing something you no longer need to carry. The night is quiet around you. You are safe. You are still. Let the gentle dark hold you and allow yourself to simply rest, to soften, to let go a little more with every slow and easy breath. The Moon's gravity causes Earth's ocean tides. As the Moon moves through its orbit, its gravitational pull gently tugs at the oceans below, drawing water toward it in a slow, rhythmic swell. The seas rise and fall in response twice each day, as reliable and steady as breathing. This ancient rhythm has shaped coastlines, guided migrations of creatures, and set the pulse of life along every shore. It is a quiet conversation between two worlds, the Moon pulling softly, the ocean answering, over and over, without end. The Moon formed approximately 4-5 billion years ago, likely from a giant impact between Earth and a Mars-sized body called Theia. Scientists believe that in the early solar system, this world-sized object struck the young Earth at an angle, sending an enormous cloud of vaporized rock and debris spiraling outward into orbit. Over time, that cloud slowly cooled and gathered, piece by piece, into the moon we know today. It is a quiet origin story, a collision so ancient it belongs to a time before any living thing existed, before the ocean settled, before the sky was blue. The moon has no atmosphere and experiences temperature extremes from 127 degrees Celsius to negative 17.3 degrees Celsius. Without air to hold warmth or soften the sun's rays, the lunar surface swings between fierce heat and deep cold with every turn from day to night. In sunlight, the ground bakes. In shadow, it freezes in silence. No wind moves across it. No weather changes it. It is a world of absolute stillness, of long quiet days and longer quiet nights, its surface unchanged for millions of years, patient and undisturbed. The far side of the moon was first photographed by the Soviet Luna 3 spacecraft in 1959. For all of human history before that moment, the far side had never been seen. The moon's slow, synchronized rotation keeps one face permanently turned away from Earth. When Luna 3 swung around and sent back its blurry, historic images, humanity glimpsed for the first time a landscape that no human eye had ever known. It was rougher, more cratered, quieter than the near side, a hidden face finally, gently revealed after billions of years of turning away. Water ice has been confirmed in permanently shadowed craters at the moon's poles. In the deep floors of certain craters near the lunar poles, sunlight never reaches, not for billions of years. In that eternal cold and darkness, water ice has quietly accumulated, ancient and still. Scientists confirmed its presence using orbital instruments and surface data, finding it tucked into the shadows like something carefully preserved. It is a gentle surprise that even on this dry, airless world, water found a way to hide and stay, patient in the dark. Mars is called the Red Planet because of iron oxide on its surface. Across its plains and hills and vast ancient deserts, the soil of Mars is dusted with iron oxide, rust, giving the whole world a warm, reddish tone that is visible even from Earth with the naked eye. It glows in the night sky like a faint ember, a soft red point of light that ancient peoples watched and named long before anyone knew what it truly was. Up close, the landscape is ochre and amber and dusty rose, a quiet world painted in the colors of a long, slow sunset. Mars has the tallest volcano in the solar system, Olympus Mons, standing about 22 kilometers high. It rises so gradually from the surrounding plain that if you stood at its base, you would not know you were on a volcano at all. Its slopes are too gentle, its scale too immense for any single view to hold. It is nearly 3 times the height of Mount Everest, and so wide that its edges stretch beyond the horizon. It is simply enormous and enormously still, a vast ancient mountain that has not erupted for millions of years, resting quietly in the thin Martian air. Valles Marineris on Mars is a canyon system stretching over 4,000 kilometers, dwarfing Earth's Grand Canyon. If you could place it on Earth, it would stretch from the western coast of the United States all the way to the Atlantic Ocean. Its walls drop kilometers deep, and its width in places spans hundreds of kilometers across. It did not form the way Earth's canyons do, carved by rushing water, but rather cracked open long ago as the Martian crust stretched and pulled apart. It is simply one of the grandest, most quietly overwhelming features on any world we know. Mars has 2 small moons, Phobos and Deimos, which are likely captured asteroids. They are nothing like our own moon, small and irregular, shaped more like lumpy potatoes than perfect spheres, tumbling gently in their orbits above the rust-colored world below. Phobos is the larger of the 2, close and quick, while Deimos drifts farther out, slow and faint. Scientists believe they were once wandering rocks from the asteroid belt, pulled in long ago by Mars's gravity and held ever since. two small companions, quietly keeping watch. Phobos orbits Mars so closely that it will eventually be torn apart by tidal forces in about 50 million years. It circles the planet 3 times every Martian day, so close that the gravity of Mars gently, inexorably pulls at it, stretching it, stressing it, drawing it ever so slightly inward with each pass. Scientists believe that one day, in the deep future, it will break apart into a ring of debris encircling Mars. For now, it simply orbits on, unhurried and unaware, a small moon living out its long, slow journey toward an inevitable, peaceful dissolution. Let yourself settle a little more deeply now. There is nowhere to be, nothing to hold on to, nothing to figure out. Let your breath come and go on its own, slow and easy. Feel the weight of your body resting, fully supported, completely still. The thoughts that drift through your mind can simply pass like clouds moving across a wide, quiet sky, noticed softly, then released. You are safe, you are warm, and the only thing left to do is let go, gently, and drift. Mars has a thin atmosphere composed mostly of carbon dioxide. It is so thin that it offers almost no protection from the sun's radiation and almost no warmth. Barely 1% the pressure of Earth's atmosphere at sea level. Standing on Mars, you would feel nothing of it against your skin. And yet it is there, a faint veil of gas clinging to the planet, enough to carry dust, enough to shape the weather in its own quiet way. A whisper of an atmosphere, thin as a held breath, wrapping the red world in the gentlest of layers. Evidence of ancient river valleys and lake beds suggests Mars once had liquid water on its surface. Carved into the terrain are dry channels that wind and branch the way rivers do, and broad flat plains that may once have held quiet lakes beneath an older, warmer sky. Scientists believe that billions of years ago, Mars was a wetter world, perhaps even a blue one. That water is mostly gone now, locked in ice or lost to space, but the land still holds the memory of it, written in the shape of the ground, patient and still. Mars experiences planet-wide dust storms that can last for months. They begin as small, local swirls and sometimes grow until they swallow the entire planet in a veil of fine, rust-colored dust. The sun dims to a faint glow. The sky turns a deep, murky amber, and the whole world becomes quiet beneath the haze. These storms move slowly, settling over everything like a long, heavy sleep. When they finally fade and the dust drifts back to the ground, the landscape emerges again, unchanged and still, as if the storm had simply been a long, slow exhale. A Martian day called a sol is about 24 hours and 37 minutes long. It is remarkably close to our own day here on Earth, just a little longer. A small extra breath of time added to each rotation. Mars tilts on its axis much as Earth does, so it also has seasons, and its days and nights follow a familiar rhythm of light and dark. Scientists and engineers working with Mars rovers plan their schedules sol by sol, gently shifting their own clocks to match. It is a quiet reminder that even on another world, the days still turn. Mars has the largest dust devils in the solar system, sometimes reaching several kilometers in height. In the thin Martian air, heated by sunlight striking the surface, these towering spirals of dust rise slowly and silently into the sky, taller than any storm of this kind on Earth. They wander across the plains like slow, quiet ghosts, carrying fine red dust upward in long, graceful columns. From orbit, they leave faint, dark tracks across the landscape, tracing the paths of their gentle wandering. They are vast and strange, and yet somehow peaceful, just the planet breathing. The asteroid belt lies between Mars and Jupiter, and contains millions of rocky objects. It is a wide, quiet region of space, not a crowded wall of rock as it is sometimes imagined, but a vast, spread-out field where millions of objects drift in their own slow orbits, separated by enormous distances of empty space. Some are tiny grains, some are boulders, and a few are small worlds in their own right. Sunlight touches them softly as they turn, each one following its own patient path around the sun, unhurried, ancient, and still. The asteroid belt's total mass is less than 4% of the Moon's mass. For a region containing millions of objects, that is a surprisingly small amount, a reminder of just how spread out and sparse this quiet zone truly is. If you could gather every asteroid, every pebble, every grain of dust in the entire belt and press them together, the result would be a body far smaller than our own Moon. The belt is more emptiness than substance, more silence than stone. Ceres is the largest object in the asteroid belt and is classified as a dwarf planet. It is roughly spherical, shaped by its own gravity into a smooth, rounded form, something most asteroids never achieve. Ceres sits quietly at the center of the belt, patient and still, its pale gray surface dusted with ancient craters and faint bright spots of reflective salt. It is a small world, yet a world nonetheless, a place where sunlight falls softly and silence stretches in every direction. Ceres contains about 1/3 of the total mass of the entire asteroid belt. Though it shares the belt with millions of other objects, Ceres quietly holds dominion over them all in terms of sheer mass. Its neighbors are mostly small and irregular, tumbling slowly in their orbits, while Ceres turns with a calm, steady dignity. It is the quiet anchor of that whole wide region, not imposing, not dramatic, simply present, massive, and still, the way a deep lake is still even when surrounded by scattered stones. The asteroid Vesta is the brightest asteroid visible from Earth with the naked eye. On a clear, dark night, it shines faintly but steadily in the sky, a tiny point of reflected sunlight traveling its slow, patient orbit. Vesta's surface is unusually bright because it is composed of basaltic rock that reflects light well, a remnant of ancient volcanic activity long since cooled and stilled. To look up and find, it is to see, with your own eyes, a world hundreds of millions of kilometers away, quietly glowing. Let your body settle a little more deeply now. There is nothing to hold on to, nothing to figure out. Let your shoulders drop, let your jaw soften, let your hands rest open and easy. Each breath is a little slower than the last, each exhale carrying the last traces of the day gently away. You are drifting now, quietly and safely, through the soft dark between the stars. There is nowhere to be and nothing to do. Just this, the slow, warm rhythm of rest finding you. Most asteroids in the belt are separated by vast distances, and spacecraft can pass through without hitting anything. The popular image of a dense, dangerous field of tumbling rock is a kind of myth. In reality, the belt is almost entirely empty space. Spacecraft have passed through it many times with ease, gliding through the silence between objects that may be hundreds of thousands of kilometers apart. It is a reminder that space, even in its busiest regions, is mostly stillness, mostly quiet, mostly nothing at all. Trojan asteroids share Jupiter's orbit, clustering at the Loire and Live Lagrange points ahead and behind the planet. These two gravitational sweet spots hold thousands of asteroids in a gentle, stable embrace, locked into their positions by the balanced pull of Jupiter and the Sun. They drift along, 60 degrees ahead and 60 degrees behind the great planet, like quiet companions on the same long journey. They have traveled this way for billions of years, patient and unhurried, following Jupiter through the dark without ever drawing close. Jupiter is the largest planet in the solar system, with a diameter about 11 times that of Earth. To hold Earth and Jupiter in the mind at the same time is to feel the scale of the solar system gently expand. 11 Earths laid side by side would barely span Jupiter's width. Its vast, banded face, swirled with cream and amber and soft rust, turns slowly in space, enormous and unhurried. It is a world so large it seems less like a planet and more like a presence, filling its corner of the solar system with quiet, immovable weight. Jupiter's mass is more than twice that of all other planets combined. Every planet in the solar system, Saturn, Uranus, Neptune, Earth, and all the rest, could be gathered together, and Jupiter would still outweigh them all by a wide margin. It shapes the solar system through its gravity, the way a deep, calm center of gravity shapes everything around it, quietly, constantly, without effort. The other worlds move in their orbits partly in response to Jupiter's immense and patient pull, a gentle influence that has guided the solar system for billions of years. Jupiter is a gas giant with no solid surface. There is no ground to stand on, no shore to reach, just layer after layer of gas growing slowly denser as you descend, the atmosphere thickening into liquid hydrogen far below. The cloud tops we see from space are just the beginning, a surface that is no surface at all, shifting and flowing in slow, vast patterns. Jupiter is all depth and atmosphere, a world of endless layers, each one pressing quietly into the next, all the way down to a core that remains, even now, not fully understood. Jupiter's Great Red Spot is a storm that has persisted for at least 350 years. It was first observed by astronomers in the 17th century, and it has been turning ever since, a vast, slow anticyclone wider than the entire Earth. Its deep amber and rust tones swirl in long, unhurried arcs, one enormous rotation taking about 6 days to complete. It is one of the oldest known weather systems in the solar system, enduring across centuries with quiet, steady persistence. The Great Red Spot is shrinking and has been doing so since at least the 19th century. When astronomers first carefully measured it, the storm spanned roughly 40,000 kilometers across. Today it is considerably smaller, perhaps half that width or less, still vast by any earthly measure, but quietly diminishing over time. Scientists continue to watch it with gentle curiosity, unsure of what its future holds. There is something quietly moving about a storm that has raged for centuries, slowly, softly fading. Jupiter has the shortest day of any planet, rotating once every 9 hours and 56 minutes. For a world so enormously large, this speed is remarkable. Its equator moves at roughly 45,000 kilometers per hour as it spins. This rapid rotation is part of why Jupiter's clouds form into those long, parallel bands, the atmosphere stretched and sorted by the constant, steady turning. The planet spins through space with a calm, relentless rhythm, day after day, faster than any other world. Jupiter has at least 95 known moons. They range from tiny, irregular rocks, just a few kilometers across, to worlds larger than some planets, each following its own quiet orbit around the great planet. Some cluster close, moving in swift, tight circles. Others drift far out in wide, slow paths that take years to complete. Together they form a small solar system of their own, a gentle family of worlds all held in place by Jupiter's vast and patient gravity. Ganymede, Jupiter's largest moon, is the biggest moon in the solar system and is larger than the planet Mercury. It is a world of ancient, grooved terrain and vast icy plains, its surface marked by billions of years of quiet history. Ganymede even has its own magnetic field, a rare and gentle distinction among moons. Seen from a distance, it glows with a soft, cool light, a world unto itself, orbiting Jupiter in a slow, steady arc, larger than a planet yet content to be a moon. Let yourself rest now, just for a moment. Feel the weight of your body settle gently, as if the ground beneath you is holding you with quiet care. Let your breath move slowly in and out, each exhale carrying a little more of the day away. There is nothing to hold on to right now, nothing to solve or remember. You are simply here, warm and still, drifting softly in the dark, as the vast and peaceful universe turns slowly around you. Europa, one of Jupiter's moons, has a global saltwater ocean beneath its icy crust. The surface is smooth and pale, crisscrossed with long reddish lines where the ice has cracked and shifted over time. Beneath that shell of ice, Scientists believe a liquid ocean stretches across the entire moon, kept warm by the tidal flexing of Jupiter's gravity. It is one of the most intriguing places in the solar system, a hidden sea, dark and still, sealed beneath miles of ancient ice. Io, Jupiter's innermost large moon, is the most volcanically active body in the solar system. Its surface is constantly being remade, covered in sulfur and lava flows in shades of yellow, orange, and deep red, dotted with hundreds of active volcanoes. Enormous plumes of gas and ash rise silently into the thin sky above it. Io is squeezed and stretched by Jupiter's immense gravity, and that constant flexing generates the heat that keeps it churning. It glows like an ember, restless and alive. See, Callisto, Jupiter's outermost Galilean moon, is one of the most heavily cratered objects in the solar system. Its ancient dark surface has been struck so many times over billions of years that it carries the record of nearly every impact, layer upon layer of quiet history written in craters. Unlike its siblings, Callisto shows little sign of geological activity. It is still and unchanged, a world that has simply endured. It drifts in its wide, slow orbit, carrying its scars with calm and unhurried dignity. Jupiter's faint ring system was discovered by the Voyager 1 spacecraft in 1979. Unlike Saturn's brilliant icy rings, Jupiter's are thin and dark, made mostly of fine dust knocked from its inner moons by tiny meteorite impacts. They are nearly invisible from Earth and were unknown until Voyager passed through the Jovian system and looked back. Seen in silhouette against the soft glow of the sun, they appear as delicate, ghostly halos, quiet and easy to miss. But there, encircling the great planet in a gentle, dusty embrace. Jupiter acts as a gravitational shield, deflecting many comets and asteroids away from the inner solar system. Its enormous mass bends the paths of wandering objects, pulling them into new trajectories, sending them looping out into the far reaches of space rather than inward toward the rocky planets. Scientists believe that without Jupiter's quiet, steady influence, Earth and its neighbors might have experienced far more collisions over the billions of years of the solar system's history. It is a silent guardian, vast and unhurried, simply doing what gravity does, drawing things gently toward itself and away from somewhere else. Jupiter's magnetosphere is the largest planetary magnetosphere in the solar system, extending up to 7 million kilometers toward the Sun. It is an invisible bubble of magnetic force, immense beyond easy imagining, stretching out into space in every direction and dwarfing the planet itself many times over. Charged particles from the solar wind press against it, and the magnetosphere holds them at bay, shaping the invisible architecture of the space around Jupiter. If it could be seen from Earth, it would appear larger in the night sky than the full moon. Saturn is the second largest planet and is famous for its spectacular ring system. Even through a small telescope, it stops the eye immediately, a pale golden world encircled by broad, luminous bands that seem almost too beautiful and too orderly to be real. Saturn sits quietly in its orbit, unhurried, radiating a kind of calm grandeur that has captivated every person who has ever turned a lens toward the sky. It is one of the great wonders of the solar system, a planet that seems almost to have been arranged with care. Saturn's rings are made mostly of ice particles, rocky debris, and dust. The ice is the brightest part, countless tiny fragments and larger chunks, each tumbling slowly in its own orbit, catching and scattering sunlight like a field of floating snow. Some pieces are as small as grains of sand, others are as large as a house. Together they form those brilliant, sweeping bands, each particle traveling in quiet company with billions of others, circling the planet in a slow, endlessly patient procession. Saturn's rings extend up to 282,000 kilometers from the planet, but are typically less than a kilometer thick. They reach across an extraordinary distance, wide enough to span much of the space between Earth and the Moon, and yet in the vertical dimension they are almost impossibly thin, like a sheet of paper stretched across a room. From the side, they nearly vanish. It is one of the most striking contrasts in the solar system, something so vast in one direction and so delicate in another, paper-thin and enduring all at once. Saturn is the least dense planet in the solar system and would float in water. Its vast volume is filled mostly with hydrogen and helium gas, so loosely packed that the whole planet, on average, is lighter than water. It is a strange and gentle thought. A world larger than any other in the solar system, save Jupiter, and yet somehow buoyant, airy, almost weightless in its composition. Saturn drifts through space like something vast and cloud-like, more atmosphere than substance, a planet made mostly of sky. Let your body grow a little heavier now, settling gently into wherever you are resting. There is nothing you need to think about, nothing you need to hold on to. Let each breath come a little slower, a little softer, carrying you quietly downward into stillness. The day is done, and the world is at rest. You can let your thoughts drift the way clouds drift, slowly, without direction, dissolving into the quiet dark. There is only this soft, unhurried moment, and you are safe within it. Let yourself go. Saturn has at least 146 known moons, more than any other planet. They range from tiny, irregular chips of rock and ice tumbling in distant orbits to large, complex worlds with their own weather and geology. Some shepherd the rings, keeping their edges crisp and defined. Others orbit in unusual tilted paths, likely captured long ago from the outer solar system. Together they form a whole small family of worlds, circling Saturn in quiet, steady company, each one following its own patient path. Titan, Saturn's largest moon, has a thick nitrogen atmosphere and lakes of liquid methane and ethane on its surface. It is a world wrapped in a dense orange haze, its surface hidden from view beneath layers of smog and cloud. Below that haze, rivers of liquid methane carve channels through dark plains, and shallow lakes of ethane lie still and glassy in the polar regions. It is cold and dim and utterly unlike Earth, and yet with its thick air and its liquid-filled basins, it carries a strange, quiet echo of familiarity. Titan is the only moon in the solar system known to have a dense atmosphere and stable surface liquids. Every other moon is airless, or nearly so, bare rock and ice exposed directly to the cold of space. But Titan holds its thick blanket of nitrogen close, and beneath it, liquids pool and flow and gather in lakes, following a slow methane cycle that mirrors, in its own alien way, the water cycle of Earth. It is a world with weather, with seasons, with a kind of slow and frigid hydrology, a moon that breathes. Enceladus, a small moon of Saturn, has geysers that eject water vapor and ice into space. Near its southern pole, long fractures in the ice, called tiger stripes, release great plumes of fine, glittering particles that rise silently upward and drift away into the dark. These geysers do not roar or thunder. They breathe, slowly and steadily, sending soft veils of ice crystals into the emptiness above. It is one of the quietest, most delicate spectacles in the entire solar system. Enceladus has a subsurface liquid water ocean that may be capable of supporting life. Beneath its bright frozen shell, scientists believe a global ocean of liquid water lies in quiet darkness, kept warm by the gentle kneading of Saturn's tidal gravity. The water is thought to be salty and mineral-rich, carrying the chemical ingredients that life as we know it tends to need. Whether anything stirs within that hidden sea, we do not yet know, but the possibility rests there softly, like a question held in patient silence. The Cassini spacecraft discovered that Enceladus's geysers contribute material to Saturn's E-ring, As those fine plumes of ice and vapor rise from the moon's southern pole and drift outward, they spread slowly through space, joining the vast, diffuse band of Saturn's outermost ring. In this way, a small moon feeds a ring, a quiet, continuous act of giving, grain by grain, over millions of years. The E-ring is the faintest and most gossamer of Saturn's rings, and Enceladus is its gentle, patient source. Saturn's moon Mimas has a large impact crater that makes it resemble the Death Star from Star Wars. The crater, called Herschel, is enormous relative to the size of the moon, so large that the impact that created it nearly shattered Mimas entirely. It sits on one face of the small, round moon, like a great, still eye, its walls rising and its central peak rising from its floor. It is a quiet reminder of the ancient violence of the solar system, now frozen and still, worn smooth by time and cold. Saturn's hexagonal polar storm is a unique six-sided jet stream at its north pole. It is one of the most extraordinary shapes found anywhere in the solar system, a near-perfect hexagon of flowing cloud and wind, each side stretching roughly as wide as Earth itself. Scientists believe it is formed by the interaction of deep atmospheric currents, its geometry held stable by Saturn's rotation. From above, it looks like something drawn with great care and patience, a slow, enormous geometric bloom of cloud, turning quietly in the polar dark. The Cassini-Huygens mission revealed Saturn's system in unprecedented detail between 2004 and 2017. For 13 years, the spacecraft moved quietly through the rings and moons, sending home image after image of a world more beautiful and complex than anyone had fully imagined. It dove between the rings and the planet, skimmed past Titan again and again, and watched Enceladus breathe its plumes. At the end of its mission, it was guided gently into Saturn's atmosphere, becoming part of the planet it had spent so long exploring. It was a quiet and graceful farewell. Uranus is an ice giant composed mainly of water, methane, and ammonia ices. Unlike the gas giants Jupiter and Saturn, which are mostly hydrogen and helium gas, Uranus holds a deep, dense interior of icy materials compressed under tremendous pressure. Its pale blue-green color comes from methane in its upper atmosphere, which absorbs red light and lets blue and green wavelengths drift back out into space. It is a cool, quiet color, the color of deep water or distant winter sky, serene and still against the black. Let your body settle a little deeper now. Feel the weight of your arms, your legs, your shoulders, all of it softening, releasing, sinking gently downward. There is nothing to hold and nothing to solve. Your breath moves slowly in and slowly out, like a tide that knows exactly what to do without any effort at all. Let your thoughts grow lighter, less defined, drifting apart like wisps of cloud in a wide, still sky. You are safe, you are warm, you are already drifting quietly and gently toward sleep. Uranus rotates on its side with an axial tilt of about 98 degrees. Most planets spin upright, their poles pointing more or less toward the stars above and below the solar system's plane. But Uranus rolls along its orbit like a slow, tilted wheel, its poles facing outward toward the sun at different points in its long journey. Scientists believe a massive collision long ago knocked it onto its side, and there it has remained ever since, unhurried, tilted, tracing its quiet path through the outer dark. Uranus's extreme tilt means its poles experience 42 years of continuous sunlight, followed by 42 years of darkness. For nearly half a Uranian year, one pole faces the sun without interruption, a slow, unbroken Arctic day that lasts longer than a human lifetime. Then, the planet rolls on, and that same pole turns away into an equally long, unbroken night. It is a rhythm so vast and so slow that it barely resembles anything we know of seasons or days. Time moves differently out there in the quiet, tilted dark. Uranus is the coldest planetary atmosphere in the solar system, reaching -224 degrees Celsius. Even Neptune, which is farther from the Sun, does not quite reach these depths of cold. Scientists believe Uranus releases very little of its internal heat, leaving its atmosphere to cool to extraordinary extremes. It is a cold so profound, it is almost beyond imagining, a stillness so deep that the very air has slowed nearly to silence, suspended in a vast and frozen quiet at the edge of the known. Uranus has 13 known rings, which are dark and narrow compared to Saturn's broad, glittering bands. Where Saturn's rings catch sunlight and glow like spilled silver, the rings of Uranus are made of dark, sooty material, thin, precise lines drawn quietly around the pale blue-green planet. They were discovered in 1977 when Uranus passed in front of a distant star, and the star's light briefly dimmed on either side. Subtle, understated, easy to miss, like a soft whisper beside Saturn's wide, luminous song. Uranus has 28 known moons, all named after characters from the works of Shakespeare and Alexander Pope. Titania, Oberon, Ariel, Umbriel, Miranda, their names carry the soft weight of old stories and verse. It is a gentle tradition, unique among the planets, as though astronomers wish to bring a little poetry into the cold outer dark. Each small moon drifts in its own quiet orbit, carrying a borrowed name through the long, slow years far from the warmth of the sun. Miranda, a moon of Uranus, has one of the most varied and extreme terrains in the solar system, including a cliff nearly 20 kilometers tall. Called Verona Rupes, this immense escarpment rises in silence on a world barely 500 kilometers across, a sheer towering wall of ancient rock standing at the edge of a frozen plain. Scientists believe Miranda may have been shattered by an ancient impact and slowly reassembled under its own gravity. Its fractured patchwork surface holds a quiet record of something vast and long ago. Uranus was the first planet discovered with a telescope by William Herschel in 1781. Before that night, humanity had known only 5 planets beyond Earth: Mercury, Venus, Mars, Jupiter, and Saturn, all visible to the naked eye since ancient times. Herschel, scanning the sky from his garden in Bath, England, noticed something that moved against the fixed stars. The solar system, which had seemed complete for thousands of years, quietly grew larger in a single evening. A door opened, gently, into a wider dark. Neptune is the farthest planet from the Sun, orbiting at about 30 astronomical units. That means Neptune is 30 times farther from the Sun than Earth is, a distance so great that sunlight, traveling at its extraordinary speed, still takes more than 4 hours to arrive. Out there, the Sun is no longer a warm, broad presence filling the sky. It is simply the brightest star, a sharp, unwavering point of cold light in an otherwise dark and infinite field. Neptune drifts in that remote, quiet, slow and patient, and immeasurably far. Neptune was discovered in 1846 through mathematical predictions before it was ever directly observed. Astronomers had noticed that Uranus was not quite following the path their calculations predicted. Something unseen was pulling at it, tugging its orbit with quiet, invisible gravity. Working independently, mathematicians Urbain Le Verrier and John Couch Adams each calculated where the unknown planet must be. When observers pointed their telescopes to that precise location, Neptune was there, exactly where mathematics said it would be. The universe had been read like a page of quiet equations. Neptune has the strongest winds in the solar system, reaching speeds of over 2,100 kilometers per hour. On a planet so far from the Sun, receiving so little energy, such ferocious winds seem almost impossible. And yet they blow, relentless and immense, sweeping across a world of deep blue cloud. Scientists are still not entirely certain what drives them. Perhaps heat, rising from Neptune's warm interior, stirs the atmosphere into motion. Whatever the cause, Those winds move in vast, sweeping silence, unheard across the distance between worlds. Let your breath slow now, just a little more. There is nothing pressing, nothing waiting. Feel the weight of your body, heavy and soft, against whatever holds you. Let your thoughts drift without direction, not chased, not followed, simply allowed to pass. The universe is vast and unhurried, and you are a small, warm, resting part of it. You do not need to go anywhere or think anything. Just breathe, slowly and gently, and let the quiet carry you a little further into rest. Neptune's great dark spot was a storm system observed by Voyager 2 in 1989 that later disappeared. When the spacecraft swept past, it captured images of a vast, dark oval turning slowly in Neptune's southern hemisphere, a storm the size of Earth, drifting through blue clouds. But when the Hubble Space Telescope looked again a few years later, the spot was simply gone. A new one had appeared in the north. Neptune's storms are not permanent landmarks, but passing visitors, rising and fading in their own quiet time, leaving no trace behind. Neptune has 16 known moons, each one a small, quiet world drifting in the cold blue dark. They vary greatly in size and shape, some round and smooth, others irregular, like fragments of ancient ice caught in Neptune's patient gravity. Most are small enough that we know very little about them, their surfaces unseen, their nature still largely a mystery. They circle in the deep, far from the sun's warmth, companions to a world that few have ever closely seen. Triton, Neptune's largest moon, orbits in the opposite direction to Neptune's rotation, a motion that suggests it was captured long ago rather than born alongside its planet. Most moons form from the same spinning disk of material that creates their host planet, moving in the same direction, in quiet agreement. But Triton travels the other way, a wanderer that was pulled in from somewhere else, perhaps from the distant Kuiper Belt, and held ever since by Neptune's deep, steady gravity. Triton has geysers that eject nitrogen gas several kilometers into the thin cold air above its surface. When sunlight, faint as it is at such a distance, warms the dark subsurface ice, the pressure builds slowly until columns of nitrogen burst upward, carrying dark streaks of dust into the sky. They rise in slow, silent plumes, drifting gently sideways in Triton's almost absent atmosphere before fading. It is a world that breathes quietly in its own unhurried way. Triton is slowly spiraling inward and will eventually be torn apart by Neptune's gravity in about 3.6 billion years. Each orbit brings it just slightly closer, drawn inward by tidal forces in a process so gradual it is utterly imperceptible across a human lifetime. One day, far in the future, Triton will cross a boundary where gravity overcomes the forces holding it together, and it will dissolve into a ring of glittering ice and debris, a gentle, inevitable end, written in the patient laws of the universe. Neptune takes 165 Earth years to complete one orbit around the Sun. It moves so slowly through the sky that from our vantage point on Earth, it barely seems to drift at all. Neptune was discovered in 1846, and it did not complete its first full orbit since discovery until 2011, within living memory. To stand on Neptune, if one could, and watch the Sun complete a single circuit overhead, would require more than a century and a half of patient waiting. Voyager 2 is the only spacecraft to have visited Neptune, flying by in 1989. It arrived after a journey of 12 years, crossing the vast emptiness between worlds, and spent just a few hours close enough to see Neptune in detail. In that brief passage, it returned images of blue clouds, dark storms, and the strange terrain of Triton. Then it continued onward, leaving Neptune behind forever. To this day, no other mission has returned. Neptune remains, in many ways, a world seen only once from a distance in passing. The Kuiper Belt is a region of icy bodies extending from Neptune's orbit outward, to about 50 astronomical units from the Sun. It is a broad, diffuse disk of frozen worlds, remnants from the early solar system that never gathered into a planet, preserved in the cold dark beyond Neptune's reach. Billions of icy objects drift there in slow, wide orbits, mostly unseen, mostly unnamed. The Kuiper Belt is not a wall or a barrier, just a quiet, vast scattering of ancient ice, drifting in the long silence. Pluto is the largest known object in the Kuiper Belt, a small round world of ice and rock drifting in the cold far reaches of the solar system. For decades after its discovery in 1930, it was considered the ninth planet, a lonely outpost at the edge of the known solar system. But as astronomers looked more carefully into the Kuiper Belt, they found that Pluto was not alone out there. It was the largest member of a whole family of frozen worlds, quietly sharing that distant space. Pluto was reclassified as a dwarf planet by the International Astronomical Union in 2006. The decision was not a demotion born of indifference. It was a recognition that the solar system is richer and more varied than once believed. Pluto belongs to a whole class of round, icy worlds beyond Neptune, and naming it a dwarf planet placed it among its true companions. It remains a remarkable world, unchanged by any label, still drifting, still turning, still holding its moons close in the quiet dark. Let yourself settle now, gently and completely. There is nothing left to hold on to tonight, no thought that needs following, no question that needs answering. Feel your breath moving slowly in and out, easy and unhurried. Let your body grow heavy and warm, sinking softly into rest. The solar system drifts on in its vast, patient silence, all those distant worlds turning slowly in the dark, and you, here, are perfectly still at the center of your own quiet universe. Let sleep come now, soft and slow, like light fading at the edge of a long and peaceful day. Pluto has 5 known moons, the largest of which is Charon. The other 4, Styx, Nix, Kerberos, and Hydra, are small and irregular, tumbling slowly in distant orbits. But Charon is something else entirely, a large, round world, gray and still, holding close to Pluto in a quiet gravitational embrace. Together they form a paired system unlike almost anything else we know, 2 worlds, side by side, drifting through the cold outer dark. Charon is so large relative to Pluto that the two are often considered a double dwarf planet system. Their gravitational center, the point around which they both orbit, sits in the empty space between them, not inside either world. They are tidally locked to each other, each always showing the same face to its companion. It is a rare and quiet kind of companionship, 2 small frozen worlds, forever facing one another across a narrow stretch of dark. The New Horizons spacecraft performed the first flyby of Pluto in July 2015, revealing a heart-shaped nitrogen ice plain. After 9.5 years of travel across the solar system, the spacecraft swept past Pluto in a single quiet afternoon, sending back images no one had ever seen. There, on the surface, was a vast, pale plain, shaped unmistakably like a heart, smooth, bright, and still. Scientists named it Tombaugh Regio in honor of the man who first discovered Pluto. Pluto's surface features mountains of water ice, rising several kilometers high. Despite its small size and great distance from the Sun, Pluto is not a flat or featureless world. Ancient ranges of frozen water stand tall across its surface, their peaks catching the faint, distant sunlight. It is remarkable, water ice so cold and rigid that it holds its shape like stone, forming quiet, enduring mountains at the edge of the solar system. Eris, discovered in 2005, is a dwarf planet in the scattered disk, slightly smaller in size than Pluto. It was found far beyond the Kuiper Belt, drifting in a long, looping orbit that carries it to enormous distances from the Sun. Eris is dense and bright, its surface coated in pale frozen methane. When astronomers first measured it, they thought it might even be larger than Pluto, and that question changed everything about how we think of the outer solar system. The discovery of Eris directly triggered the debate that led to Pluto's reclassification. Here was a world so similar to Pluto in size and nature that astronomers had to ask, if Pluto is a planet, is Eris one too? And if so, how many more might be out there? Rather than keep adding planets to the list, the International Astronomical Union defined a new category: dwarf planet and Pluto. Eris and their kin found a quieter, more fitting home within it. Makemake and Haumea are two other recognized dwarf planets in the outer solar system. Makemake is a cold, reddish world with a thin, temporary atmosphere that forms only when it draws closer to the sun. Haumea is stranger still, a fast-spinning, oddly shaped world with two small moons and a faint ring. Each of these distant worlds is different, each quietly remarkable in its own way, all of them drifting together in the cold outer reaches of the solar system. Haumea spins so fast that it has been flattened into an elongated egg shape. It completes one full rotation in just under 4 hours, faster than any other known dwarf planet. That rapid spin has pulled its equator outward and compressed its poles, stretching it into an oval form, unlike the tidy round spheres we usually picture when we think of worlds. It tumbles through the outer dark in its own unusual way, unhurried in its orbit even as it spins so swiftly. The scattered disk is a region of icy bodies, with highly elliptical orbits beyond the Kuiper belt. Unlike the relatively flat, circular paths of Kuiper belt objects, scattered disk bodies follow long, looping trajectories, carrying them far out into the dark and then swinging them back inward. They are thought to have been flung into these wild orbits by gravitational encounters with Neptune long ago. They drift now in vast, sweeping paths, slowly tracing ancient scars left by the early solar system. Sedna is a distant trans-Neptunian object with an orbital period of about 11,400 years. It follows one of the most elongated orbits of any known body in the solar system, swinging from just inside the scattered disk all the way out toward the inner edge of the Oort cloud. Right now, Sedna is drawing closer to the Sun, its nearest approach in thousands of years. It is a world that has been traveling since before the first humans walked the Earth, drifting on in its long, patient arc. Let your body settle a little more deeply now. There is nowhere to be, nothing to hold on to, nothing left to figure out tonight. Let your shoulders soften, let your jaw release. Let each breath come and go on its own, without any effort at all. You are resting at the edge of something vast and quiet, and all of that vastness is simply here with you, calm and still. Sedna's unusual orbit suggests the possible existence of an undiscovered large planet in the far outer solar system, sometimes called Planet 9. Sedna's path is so strangely elongated that scientists believe something massive may be pulling at it from a great distance, a world we have never seen, hiding far beyond the known edges of our solar system. It is a quiet mystery held gently in the mathematics of motion, a whisper from the dark suggesting there may be more to discover, drifting patiently out there in the deep. Quaoar is a Kuiper belt object with its own small moon, Waywatt, and possesses a ring system at an unexpectedly large distance from its surface. Scientists were surprised to find Quaoar's ring orbiting so far out, farther than current theories predicted rings could survive. And yet there it is, a faint, delicate band, circling this small, icy world, quietly defying expectation. Even here, in the cold and distant reaches of the outer solar system, nature finds its own gentle order. Long-period comets originate from the Oort cloud, a vast spherical shell of icy bodies surrounding the entire solar system. These comets travel inward from unimaginable distances, drawn by the sun's gravity on journeys that take thousands or even millions of years. They arrive as silent travelers from the outermost edge of everything we call home, carrying ice and dust that has been preserved since the solar system's earliest days. They are messengers from the very beginning, drifting inward on long, unhurried arcs. The Oort cloud extends from about 2,000 to 100,000 astronomical units from the Sun. At its outermost edge, the Sun would appear as nothing more than an exceptionally bright star, still the center of everything, but impossibly distant. This vast spherical shell surrounds the entire solar system like a gentle, invisible cocoon, holding countless billions of icy bodies in slow, patient orbits. It is the outermost boundary of our solar family, stretching nearly halfway to the nearest star. Halley's Comet is the most famous short-period comet, and returns to the inner solar system approximately every 76 years. It has been observed and recorded by humans for at least 2,000 years, appearing in ancient texts, tapestries, and sky journals from cultures around the world. Each return is a reunion of sorts, the same icy traveler sweeping back into the warmth of the inner solar system, briefly brilliant, then retreating again into the dark. The last visit was in 1986, and it will return again around 2060. Comets develop a glowing coma and tails of gas and dust as they approach the Sun. As a comet warms, ices on and beneath its surface begin to sublimate, turning directly from solid to gas, releasing dust and vapor in a soft expanding cloud called the coma. This glowing halo can grow larger than some planets. The tails stream outward behind it, shimmering in the solar light, filling the sky with quiet, transient beauty before the comet sweeps away again into the cold. A comet's dust tail always points away from the Sun due to radiation pressure, while its ion tail points directly away along the solar wind. These two tails are subtly different. The dust tail curves gently, following the arc of the comet's path, while the ion tail is straighter and faintly blue, pushed precisely by the invisible flow of charged particles streaming from the Sun. Together they form a soft, luminous pair, always reaching away from the warmth, always pointing outward into the open dark. The heliopause is the boundary where the solar wind is stopped by the interstellar medium, marking the true edge of the heliosphere. Here, the constant outward flow of charged particles from the Sun finally loses its battle against the pressure of the space between stars. The solar wind slows, falters, and stops, and beyond this invisible line, interstellar space begins. It is the last threshold of our Sun's direct influence, a boundary as vast and quiet as anything the solar system contains. Voyager 1 crossed the heliopause in 2012, becoming the first human-made object to enter interstellar space. Launched in 1977, it has been traveling for decades, carrying a golden record of sounds and images from Earth. When it crossed that final boundary, it carried with it a small piece of humanity into the space between stars, a quiet, remarkable achievement. It continues outward still, moving through a darkness our Sun no longer touches, a tiny human-made traveler in an immeasurably vast universe. The solar system is located about 26,000 light-years from the center of the Milky Way galaxy. We sit neither at the heart of our galaxy nor at its outermost edge, but somewhere quietly in between, nestled within one of the Milky Way's spiral arms. From here, the galactic center glows as a distant, soft band of light, vast and unhurried. We are one small system among hundreds of billions, resting gently in a galaxy so wide it takes light itself tens of thousands of years to cross. The solar system orbits the center of the Milky Way at about 220 kilometers per second, completing one full orbit every 225 million years. And yet we feel none of it, no rush, no pull, no sense of motion at all. We simply rest here, carried along in a great slow circle through the galaxy, as we have been for billions of years. You, too, are part of this quiet journey, breathing softly, held by the Earth, carried carried by the sun, turning gently through the Milky Way. There is nowhere you need to be. Let your eyes grow heavy now. Let the stars hold you. Good night.